Welcome back. In the previous video, I defined a simple problem. In this video, we are going to develop a solution for the same. So let's start. Here is my example application. I am creating a Spark session. Then I have defined the schema for my input records. The next step is to read the records from the Kafka server. Kafka records are a key value pair, right? So the first step is to take out the value and create a data frame. All these steps are standard and you already learned it in the previous lectures. Let me run it once and show you the data frame schema. Great. So we have a value.created_time and value.type and so on, right? I want to make some changes to this data frame. The first thing is to select the value.star. Why am I doing this? Well, I do not want to refer my columns using value.syntax. Let me show you. Print the schema once again. Do you see the difference? Now the value is gone and I can simply use the column names without prefixing the value dot. Great. What is next? The current data frame looks like this. However, I want to convert it to something like this. Why do I want to do it? Look at the expected output. I am expected to calculate the sum of buy and the sum of sell, right? If I can separate these values in two columns, I can simply apply the sum function, isn't it? Great, so let me transform the data frame. I'll use the with column to fix the created time column. This column is a string, but I want it to become a timestamp. So I can use the toTimestamp function. Now I will again use the with column to add a new field. The name of this field is buy, right? How do I get the value for the buy? Case when type equal to buy, then take the amount, else take 0. Make sense? Similarly, you can add one column for the sell. Done. What is next? Simple. Start with this data frame. Group by a time window. And we want to use the created time column for creating the window. The window duration should be 15 minutes. Make sense? Remember, I told you that the tumbling time window is nothing but a group by column. My requirement is to group it only by 15 minutes of time window. However, if you have a requirement to group your record for multiple columns, you can also use those columns. For example, we can add one more level of grouping for the broker code. If you do this, we will be creating 15-minute windows for each broker. But I don't have this requirement, so let me remove it. Great, so my record is now grouped by 15 minutes of tumbling time window based on the created time field, right? What is next? Simple. Aggregate it for sum of buy and also sum of sell. Let me give an alias for these two columns. Done. What output do you expect? Let me look at the schema. Here it is. So I'll get 3 columns. The first field is the window. The window field has got the start and the end timestamps. The other 2 fields are the 2 sums which I calculated, right? So it looks something like an expected output, isn't it? We have the start time, end time, buy and sell. The net value is nothing but the difference between the buy and sell. We are almost there, but not exactly. In fact, we are only halfway done. I'll explain it, but let's try to run it with some sample inputs. But before that, let me create a well-formatted output data frame. Then we create a query and sync the output to the console. In the real life project, I should sync the output to a database table. The target database could be a Spark database or it could be an RDBMS such as Postgres. Why database? Because my visualization team should read the sync table and create a graph, right? And they cannot read from Kafka or console sync. They should be expecting a database table that they can read using the ODBC or JDBC connection, right? I'll cover that part separately, but for now, let me sync it to the console. I'll use a 1-minute trigger. I'm expected to give a 15-minute trigger, but let me use a 1-minute trigger for testing it quickly. Remember, the trigger has nothing to do with the 15-minute time window, right? Great. We are now ready to run it. In the previous lecture, I plotted 6 events. Here are those 6 events. I have listed them here in the same order as they should reach to our Spark application. The first message, then second, third, fourth, then we have a latecomer, and finally, we have our last sample message. Make sense? Let me run the Kafka cluster and simulate the scenario. Let me start the producer. I'm going to send the first 2 events in advance. Both of these events are between 10 and 10:15, right? So I'm expecting Spark to create one window from 10 to 10:15 and calculate sum of these 2 events. Let me run it and see what happens. Great. Do you see the outcome? We have one window. The start time is 10 and the end time is 10:15. Both the transactions were buy, so we do not see any sell value. The sum of the buy value is 800, correct? Now let's assume that we got the third event. The third event happened at 10:20. No matter when it arrives at your system and when we are processing it, the event happened on February 5th, 2019 at 10:20 AM, right? So the event belongs to a window which starts February 5th, 10:15 to 10:30 AM. Make sense? Now let me send the next event. What do you expect? Make a pause and think about it. This event goes to a new window, 10:30 to 10:45. Why? Because this event was generated at 10:40, right? Now comes the latecomer. This 10:25 guy is coming after the 10:40 record has already occurred. So, which window does it belong to? This record is coming late, but it belongs to 10:15 to 10:30 window. We already passed that 10:15 to 10:30 window. Now we are running in the 10:30 to 10:45. However, this 10:25 guy still belongs to the window where it should. So, Spark will take the older window from the state store, update it with the information of this new latecomer record, and give us a newly updated state of the same old window. And that's what we see here. Let me scroll up and see the older state. Here it is. So, we closed this window earlier with 800 buys and 0 sell. Unfortunately, a record for this window was stuck somewhere, so this window's results are not correct. However, nothing to worry about. Whenever you get the late record, Spark will take care of updating the status of the same window and send you the updated values. That's what we see here in the end. Make sense? Let me send the last record also. Here is the outcome. So how many output records have we got? I copied all the records and arranged them. Here it is. So this is what we received. 4 records. In fact, we got 5 records, but one of them was the update for the earlier record caused by the latecomer. But the final result is the 4 records, and I arranged them in order. Is this what we wanted? No, we wanted something similar, but this is not exactly what we wanted to get. Let me show you the graph. Here it is. So if you look at this, each record is a cumulative sum. It is a kind of running total. When we say 1500 buy at 9:30, that means total purchases till 9:30 is 1500. Then the total purchases till 9:45 is 2300. How? Purchases till 9:30 was 1500. Then we got some more purchases and the total became 2300. But what do we have? We have a purchase between 10 to 10:15. Then we have a purchase between 10:15 to 10:30. We wanted total purchases till 10:30 and this value should have been 1600. Make sense? So we are half done yet. We still need to add some more code to get the running total like this. If this was a batch processing application, I could easily do it in the same application adding the following code. Let me stop the application. Delete the checkpoint directory. Comment this streaming query. Change the read stream to read. Now it's a batch application. And now I can run this application like a batch application. Let me run it. Here is the output. This is what we expected. The running totals of buy and sell and the net value. However, Spark Stream does not allow you to apply analytical functions and windowing aggregates inside a streaming query. I hope they might find a way to support analytical queries and windowing aggregates in the future versions. However, as of Spark 3.0, these things are not supported. The only window aggregate which you can get is the time-based windows and other standard aggregations. What does it mean? It means you cannot use windowing aggregates, rollups and cubes. So what is the workaround? Simple. If you take the current example, we can do the heavy lifting using stream processing. This aggregate will consume all the millions of transactions and produce you a small and tiny set of aggregated results. These aggregated values are small in number. So you can sync it to an RDBMS and let your visualization team compute the running totals. If you are using Postgres, they can do it using simple Postgres SQL expressions. Make sense? Great. Let me summarize the takeaway of this video. In this video, in tumbling window aggregates, we saw the treatment of late coming records. The latecomers are also aggregated in their respective time windows even if they arrive late. However, the late record will cause an update for the older window, and your sync should handle the updates. Finally, we learned that Spark Streaming does not support analytical functions and windowing aggregates. The workaround uses Spark Streaming for heavy lifting and creates a separate application using batch processing capabilities for handling those requirements. Alternatively, you can sync the output to a RDBMS and handle those simple things in RDBMS. Spark Streaming will anyway help you to reduce the volumes applying the first level of aggregations. That's all for this video. See you again. Keep learning and keep growing.